Hello and welcome to SAS Junior Maths. Today we are going to be looking at questions on logarithm. So let's look at this question. The question says, find the values of x in the following. Find the values of x in the following. A, log x base 10 equals 3. But before we look at this, I want us to understand something. Let me set an example. Let's say we are given log 49 base 7 equals 2. What does this mean? It means that 49 equals 7 raised to power 2. That is, this base will rise to meet what we have here so that it will become 7 raised to power 2. This base will rise to meet the result we have here so that it will change to its power. Then it becomes 7 raised to power 2 equals 49. If you have something like this, it means that this base raised to the power or raised to its power, which is 2, will automatically give us 64. So that's what this thing means. Let me start another example again. Let's say we have log 7. Now, what does it mean? It means that 7 raised to the power of 1 will give us 7. 7 raised to the power of 1 will give us 7. So automatically I will say 7 equals 7 raised to power 1, and so on and so forth. So now we are going to be looking at these questions one after the other. Now, so what we've just done has to do with, the question says find the values of the following, of x in the following. A, log x base 10 equals to 3. We want to change this logarithmic function to indices or to indicial function. Now, indicial function here means, or indicial equation here means changing it to indices, from logarithm to indices, or from logarithmic form to indices form. So what do we do? The first thing is, since you have to find the value of x, so the first step is the logarithm will not be there because you are changing it from logarithmic form to indices form. So in this case, I will say x equals 10 raised to power 3. So this base will rise to meet this 3 so that it will raise it to its power. So that this 10 will raise this 3 to its power. So we have x equals to 10 raised to power 3, and 10 raised to power 3 means 10 times 10 times 10, which is equal to 1,000. So x is 1,000. What does it mean? It means that the result, if I should place it here, that is log 1,000 base 10, then my answer will give me 3. That's what it means. Now let's move on to the next one. The next question is B, log x base 2 equals to minus 5. Log x base 2 equals minus 5. We want to change this from logarithmic function to, or from logarithmic form rather, to indices or indicial form. So what do we do? Since we are switching to indices, the next thing we are going to do is this base will rise so that it will raise this minus 5 to its power. That is 2 raised to power minus 5. And once this goes to this region, that is the right hand side, then this x will be standing alone equals to 2 raised to power minus 5. So that's what this thing means. And if I should analyze or continue, it means 1 over 2 raised to power 5, and my x equals 1 over 32. So it means, literally speaking, it means 1 over 32 is the answer to this question here. Now let's look at C. Log 36 base x equals 2. Log 36 base x equals 2. Let's not forget that if you want to switch from logarithm form to indices form, this base will rise, will go to the right hand side and raise this 2 to its power so that this 36 will stay alone. So we have 36 equals x raised to power 2. and of which is the same thing as saying x raised to power 2 equals 36. So what do? I will say x raised to power 2 equals, I will break this down 36 to a number in such a way that it will be raised to its power, so that the power will be the same. So the only way I can do is just to, though not really the only way, but the way at which I can break this 36 down is 6 raised to power 2. Why? So that the power can be the same. And in law of indices, if the powers are the same, we can always equate its base, just like exponential equation. If the powers are the same, we can always equate its base. So in this case, the powers are the same. I'll just say equate base, and my answer is x equals 6. So 6 is that answer, or 6 is that base, in such a way that when you raise it to its power, which is 6 raised to power 2, you are going to get 36 as our result. So let's move to D. D is log x base 9 equals minus 1 over 2. So the same thing, I would say, it's same thing as saying x equals 9 raised to power minus 1 over 2. And x equals 1 over 9 raised to power 1 over 2. Let's not forget that if you want to switch a negative power to a positive power, the first thing you have to do is to write 1 over. Once you've written this 1 over, it's just a trick, just letting us to know that this negative has replaced 1 over. I think that's where you can understand better. So this negative has replaced 1 over, then this 9, I will write it here, and this power will become positive. So, and of which is simple as saying 1 over square root of 9, which is 1 over 3. So my answer, my x is going to give me 1 over 3. So, and that is that for the first part. Now let's look at the second part of the question. The second part of the question is asking us to find the values of the following: log 32 base 2. Now what does this mean? This question is trying to tell us this thing literally means that how many times are we going to multiply 2 in such a way that at the end of the day it gives us 32. That's what this thing means. This thing is trying to tell us that 2 times 2 times 2, like how many times are we going to multiply 2 in such a way that at the end of the day the answer we get will be 32. So, and automatically we know that is 2 raised to power 5. That is 2 times 2 times 2 times 2 times 2. 5 times, if you multiply it 5 times, you will get 32. But now the question is, how do we solve it? How do we solve it? So now the first thing we are going to do, we are going to say, let the result be x. So it means this logarithm is going to be equal to something, and let it be x. So I will say log 32 base 2 equals x. That is what we don't know. Then we'll now switch from logarithmic form to indices form. So at the end of the day, I will say 32 equals 2 raised to power x. Let's not forget, when we are switching from logarithm to indices, this base will rise so that it can raise what we have here to its power. So 2 raised to power x, 32 equals 2 raised to power x. So I can as well say that what is that base, what is that number that when I multiply it, it will give me 32. That is, what is that number that once I multiply its duplicate, that is, if it is 2, I choose 2 times 2 times 2 times 2 times what will give me 32. And I've realized that is 2 raised to power 5 equals 2 raised to power x, meaning that 2 raised to power 5 will give us 32. If you multiply 32, if you multiply 2 5 times, it will give us 32. And let's not forget the trick. The trick has always been the lowest common base here. For the other side of the equation, try to make this number to be the lowest base. I can say that the lowest base here is 2. So try as much as possible to reduce 32 to be 2 raised to power something, so that the base can be the same and you equate powers. So when I equate powers, then I will write 5 equals to x, that is x equals to 5. So my answer is x equals 5 here. Let's look at B. B is log 16 base 4. What does this mean again? It means that what number will I raise 4 to? 4 raised to power what will give us 16? We all know that it is 2, but let's just solve it so that we'll see why it is 2. So I will say, so let the result be y. So I will now write let log 16 base 4 to be equal to y. So from here, I will say 16 equals 4 raised to power y, and of which I know that my though it's not the lowest common base, but is a signal telling you that you have to reduce this 16 to be 4 raised to power something, so that the base can be equal and you equate powers. So from here, I can say this is 4 raised to power 2 because I know that when I multiply 4 2 times, it gives me 16. So it's going to be 4 raised to power 2 equals 4 raised to power y. Then I will equate powers. So I will say 2 equals y, that is y equals 2. Please, when you're dealing with anything relating to algebra that has to do with letters, let us try as much as possible to make sure that our letters stay on our right, on our left hand side. So that is why we have y equals 2. So it means that 4 raised to power 2 will give me 16. Let's look at C. Now, C is log 1 over 2 base 4. Log 1 over 2 base 4. So I will say let log 1 over 2 base 4 equals v. So the same thing, I will say 1 over 2 equals 4 raised to power v. 1 over 2 equals 4 raised to power v. Now, let's not forget that this pattern happens to be a pattern that has to do with powers or index. That is, we need to raise something to power. So in this case, I will say 1 over 2 equals 2 raised to power 2v. But you cannot leave it as 1 over 2 here. Rather, I can as well switch it to 2 raised to power minus 1. Let's not forget that 1 over x is simply as saying x raised to power minus 1. So using this law of indices, I can as well say 1 over 2 is the same thing as saying 2 raised to power minus 1. Now I've realized that the base are equal. What am I going to do? I will just equate power. So I will equate powers. So we have minus 1 equals to 2v, that is 2v equals minus 1, divide both sides by 2, and my v equals minus 1 over 2. So it means that if I should plug in v to be minus 1 over 2, at the end of the day, I will get this as my result. That's what this thing means. So now let's look at D. So for D, we have log 1 over 3, base 9. Log 1 over 3 base 9. So I can say let log 1 over 3 base 9 equals p. So we want to switch from logarithmic form to indices form. So I will say 1 over 3 equals 9 raised to power p. So, and out of which I will say this is 3 raised to power minus 1 equals 3 raised to power 2 p, because I'm trying to make sure I raise them to the same base. Then 3 raised to power minus 1 equals to 3 raised to power 2 p when I multiply the powers together. Now the bases are the same. I will say equate powers. So I will have minus 1 equals to p, that is 2p equals minus 1. Divide both sides by 2, and my p will be equals to minus 1 over 2. So minus 1 over 2 is going to be our answer. I hope you've gained one or two things from this video. Please help in liking this video, and please help to subscribe and share to friends. Thank you.